Now the next question is find the current through the 10 ohm resistor. Okay, so here in this circuit, this question is actually different from your previous problems, because in this particular problem the current source is inside the circuit. It is not on the side of the circuit. It is not in any one of the side branches. It is inside. Here in this current source is between these two measures, right? So in that case, the problem is that you know that in order to apply Kirchhoff's voltage law, you need to know the voltage across every element inside the closed loop, right? So here in this question, what I'm going to do is, as usual, I'm going to mark my mesh current. This is I1, this is I2, and this is I3. Okay, so over here, what is the voltage across this 1 ohm resistor? I1 into 1. What is the voltage across this 10 ohm resistor? I1 minus I2 into 10. What is the voltage across this 5 ohm resistor? I2 into 5. What is the voltage across this 15 ohm resistor? I3 into 15. Now, what is the voltage across this 4 ampere current? I don't know. You see, because if you need to know the voltage across this current source, you need to know its internal resistance, or or they have to show you the voltage across, what is the potential drop across this current source. But in this question, nothing like that is shown, just a current source between two meshes. If there is a current source between two meshes, then you should apply what you call as the super mesh analysis. Super mesh analysis means it is the nothing but writing the Kirchhoff's voltage law of more than one mesh in a single equation. That is called as super mesh. That is, it is nothing but the combination of two meshes with the current source in between. See, because basically Kirchhoff's voltage law can be applied across any closed circuit, not only to just the individual meshes, it can be applied to any loops, right? So which means here you cannot apply Kirchhoff's voltage law in this mesh, because the reason is you don't know the voltage across this 4 ampere, and also you cannot apply the Kirchhoff's voltage law in this mesh, because same reason, you don't know the voltage across this current source. You know the current across this current source is 4 ampere. That means, what does this means? This is going upwards, this is going downwards, which means I3 minus I2 is equal to 4. That you have understood, but you don't know the voltage across this. Since you don't know the voltage across this, then you cannot write the KVL of this mesh, and you cannot write KVL of this mesh. But the good news is that Kirchhoff's voltage law does not include only the mesh. You can apply Kirchhoff's voltage law across any closed circuit, which means you can apply Kirchhoff's voltage law across this mesh, this outer mesh. And this outer mesh is what you call as the super mesh, right? It is this outer mesh is already called as the super mesh. That is, it is a mesh that encloses two meshes in which the current source is coming in between them. That is called as a super mesh. So in this problem, what you need to do is, basically it is super mesh analysis, right? Super mesh analysis, mesh 2 and mesh 3 will form a super mesh analysis. So you need to define the super mesh analysis equation, super mesh equation. Okay, so now let's do this question, right? So how you do this problem is that, first I write equation for mesh 1. Okay, equation of mesh 1. Okay, so what is the equation? This I1 is touching this 1 ohm and this 10 ohm, so therefore it is 11 I1. Okay, and this I2 is touching only this 10 ohm resistor, so minus 10 I2 is equal to, and this I1 is flowing through this voltage source, and this I1 is coming out of the positive terminal, which means this positive terminal is generating I1, therefore it is plus 2. Okay, so now I wrote the equation for mesh 1. Now what about mesh 2 and mesh 3? You cannot write the equation for mesh 2 and you cannot write the equation for mesh 3, because in both the cases you don't know the voltage across the 4 ampere. So what you do is, equation for super mesh 2 and 3. This is the equation that you are going to write. Equation of super mesh 2 and 3, which means mesh 2 and mesh 3 forms a super mesh, right? So how do you write the super mesh equation? Normally, just like how you write another mesh equations, only you will write the super mesh equations. See, for example, like I said before, if you are write whichever mesh equation you are writing, that corresponding current will be positive and the remaining current is negative. So here in this equation, or in this equation, it concerns super mesh 2 and 3, which means it's a combination of 2 and 3. So which means both I2 and I3 are now considered positive, and if there are any other current, that current is considered as negative. That is what is super mesh means. So that means in this case, this I1 touches this 10 ohm resistor, which means it becomes minus 10 I1, right? And now I2 and I3 is positive because this is super mesh 2 and 3. So I2 is considered positive and I3 is considered positive. And what all current I2 touches? I2 touches this 10 ohm resistor and this 5 ohm resistor. Therefore, it is 15 I2. Okay. Now, plus, now you will see this I3 current is touching only this 15 ohm resistor. So it's plus 15 I3 is equal to, there is no voltage source, right? There is no voltage source over anywhere in this super mesh. So therefore 0. Okay. Now the next equation is the equation for the current source. That is, like I said before, this I2 is going downwards, but this I3 is going upwards, and this 4 amperes also going upwards, which means the equation is I3 minus I2 is equal to 4. 3 unknown variables, 3 equations. Now you can solve it, right? So this is how we write. This is how we write the super mesh equations, right? That is, if there is a current source coming in between two meshes, then we write the Kirchhoff's we write the mesh equations of the super mesh. There is this outer layer. Okay, and in that case, the super mesh means the combination of these two meshes. So which meshes are being combined, those corresponding currents are being considered as positive and the remaining current is considered as negative. So which means this is a super mesh of 2 and 3, right? So I2 and I3 are considered as positive. I2 and I3 are considered positive and the remaining current, but here in this case there's a current called I1, so therefore I1 is considered as negative, right? And so therefore that is why this is minus 10 I1, then plus 15 I2 plus 15 I3 is equal to 0. Okay, I think maybe I can simplify this, right? This can also be written as minus 2 I1 plus 3 I2 plus 3 I3 is equal to 0. Okay, see, both this equation and this equation there is I2 in it, which means I can write this equation in terms of I2, right? Which means I3 is equal to 4 plus I2, right? I3 is equal to 4 plus I2. Okay, so that means I will substitute that over here and remove I3 from here at all. So which means this becomes I3 over here, this one, right? So it's minus 2 I1, okay, plus 3 I2, okay, plus, and what is this, 3 into, and what is I3? 4 plus I2 is equal to 0. You can solve this any way you want. What do you really need to find? You need to find the current through the 10 ohm resistor. What is the current through the 10 ohm resistor? It is I1 minus I2. So find I1 and find I2 only. Okay, so here it is. I'm going to expand this. This will become minus 2 I1 plus 3 I2 plus 12 plus 3 I2 is equal to 0. It's because minus 2 I1 plus 6 I2 is equal to minus 12, or 2 I1 minus 6 I2 is equal to 12, or I1 minus 3 I2 is equal to 6. I1 minus 3 I2 is equal to 6. So now this is equation 1 and this is equation 2. Solve for I1 and I2. So you will get, let me see, multiplying this equation with 11, right? So I will get 11 I1 minus 10 I2 is equal to 2, minus 10 I2 is equal to 2, and As for the other equation, if I multiply this into 11, 11 I1 minus 33 I2, 11 I1 minus 33 I2 is equal to, into 6 into 11 is 66, is equal to 66. So now I'm going to subtract these two equations. So this minus, this plus becomes minus, this minus becomes plus, and this plus becomes minus. So what do you get? These two will get cancelled. This will be 33 minus 10, which is minus 20, which is 23 I2. So therefore this is 23 I2, and this is 2 minus 66. 2 minus 66 is minus 64. Therefore I2 is equal to, let me see, 64 divided by 23, which is minus 2.783 amperes. Minus sign means the actual direction of the current is the one that's opposite to that of what you assumed. It means in reality current I2 is actually flowing to this. That's what it means. Okay. So I found the value of I2. Now I need to find the value of I1. So what is the equation for I1? This is a simple equation, right? I1 minus 3I2. I1 minus 3I2 is equal to 6. And which means I1 minus 3 into, and what is I2? I2 is minus 2.783 is equal to 6, right? Or in other words, I1 is equal to, minus or minus becomes plus. So this becomes 6 minus 3 into 2.783, which is 6 minus 3 into 2.783, which is minus 2.349, minus 2.349, right? Minus 2.349 amperes. So now I found the value of I1, I found the value of I2, therefore I need to find the value of I1 minus I2. Therefore current through the 10 ohm resistor is equal to I1 minus I2, which is equal to, what is I1? Minus 2.349 minus, what is I2? Minus of minus 2.783. Minus of minus is plus, which means it is 2.783 minus 2.349, which is 2.783 minus 2.7. So you will get 0.434, which is equal to 0.434 amperes. This is the current through the 10 ohm resistor. Okay, solving and all you can do however you want, that is your choice. Okay, but the only difference is the applying the super mesh equations, not the mesh equations. You cannot apply the mesh equations because you don't know the voltage across this current source. That's why you cannot apply Kirchhoff's voltage law in this mesh and in this mesh, but you can apply Kirchhoff's voltage law in this super mesh, and that's the equation you have written over here. Okay, and this is the current source equation. So from these equations you can solve for I1, I2 and I3.